Hey there, it's your old pal, Mr. Cook. We're going to go through the next couple problems on the review, on this quiz review. So we'll go through number 26 on this video, so 13 through 26. Let me take a little water break. All right, there we go. So let's find the reference angle for this. A reference angle is actually like really easy. You just got to be like aware of the vocabulary that goes along with it. Okay, so reference angle, what that means is it's the angle that is like closest, so the closest angle to the x-axis. Okay, are you ready? This is so easy. Okay, whatever your angle is drawn up as. Okay, all you got to do is just find whatever is left over to get it to the x-axis. So you stop at that terminal line right here, and then you just find that angle. Okay, that one. That's your reference angle. And look at this. It's the same thing over here. Yeah, all this fancy stuff on 14, whatever. The line stops here. There's the terminal side. How much does it take to get to the x-axis? The shortest distance to the x-axis. Those are my reference angles. It's that easy. So how far away are they? Well, I know that this straight line over here, the x-axis, like this total angle measurement from here to here is 180 degrees. So if I go from here to here, like I stop right here, that's 140 degrees. So if I take 180, subtract away that 140, there's 40 degrees left over here. So that's the reference angle. The reference angle is 40 degrees. That's how simple this thing is. It's just how far away is it from the x-axis? And it'll always be a positive angle measurement every single time, okay? So how do I get to this one over here? Oh my gosh, I have no idea. Well, first off, good Lord, radians. You can always convert it to degrees if you want. Yeah, you know what? Let's convert it to degrees real quick. So x over 180 equals my radian value, 11 pi, oh darn, 11 pi over 4 divided by pi. And remember that all that does is gets rid of the pi. So I just have an 11/4 over here. And then if I multiply both sides by 180, what do we get? Oh gosh. Let's use the little calculator there. I bet it's like 400 something. 11 over 4 times 180 equals 495. Okay, so it's a 495 degree angle. So like, you know, I go, let's kind of track it, okay? So I go 90 degrees and then 180 degrees, and then that's 270, 360, one full circle, and then 450 degrees. So if that took me to 450 degrees, right? Then that means that if I subtract that away, that gives me 45 degrees left over. So this is another 45 degrees right here, okay? So let's see here. This is 90 and 45. So that's a total of 135 degrees. So how much is left over to get to this angle measurement right over here? So this is 135. If I add those two together, 135. So if I make like that full straight angle there, that's 180. So if I take 180 and subtract away 135, that should give me the amount that I need. So 180 minus 135, that's 45 degrees. So this is a 45 degree angle. Another way that you could have figured that out is there's 90 degrees like here, right? So if this amount is 45, then this amount also has to be 45, right? To make a 90 degree angle. So there's our reference angles. So remember, when it says find the reference angle, it's really asking you to find the angle, from the terminal side that, the closest angle that you get to the x-axis. It's always referencing just the x-axis. Don't care about the y-axis, only the x-axis. Okay, find the exact value for each trigonometric function. Oh my gosh. So it looks like for this one, I've got to use my unit circle most likely if they want the exact value. So what do you think? You want to do like a practice unit circle? That was a resounding yes, right? I could hear you saying yes. So let's make a little unit circle. What do you say? All right, so make a circle. And then I've got a line in the middle. That always goes to the like 45 degree angles. And then I've got a little line like below and above the middle line. I I don't mind drawing them out. These are pretty cool. I like the unit circle. Okay, so let's do the degrees first. So I can do 0 degrees, and then like each of the it goes in a pattern. It goes up by 30, and then 15, and then 15, and then 30, and then 30, and then 15, and then 15, and then 30 for the degrees. So like watch, if I go up by 30, that's 30 degrees. Up by 15, that's 45 degrees. Up by 15 again, that's 60 degrees. Up by 30 again, that's 90 degrees. So it's that pattern, 30, 15, 15, 30. So 30 again, 120, 15, 135, 15 again, 150, and then 30 again, 180. 30, and then 15. Sorry, that looks weird. 225. I'll be careful with that. Another 15, and then 30. 15, or sorry, 30, 15, 15, and then 30 again. Okay, so there's my angle measurements. Now let's do the radians. See, for radians, I always go like in like terms of pies. Like I go full pies, half pies, quarter pies, and then I fill in the rest. So here's how I do it. I do like 0 radians. Then I go a full circle is 2 pi. So this goes to 2 pi. And then half of a circle, you know, if a full circle is 2 pi, half of a circle, so half of a circle would just give me a regular old pi. And then halfway between 0 and pi would be a pi halves. So like every time I get to a 90-degree angle, it's a pi halves. So it'd be like 0, 1 pi half, and then 2 pi halves, and then 3 pi halves on the last axis. And then in between a pi, like between 0 and 2 pi, halfway between, exactly halfway between, which would be the 45-degree angles, are fourths. So I do pi fourths. And then I just do like the odd numbers on the pi fourths for all of the 45-degree angles. So like 45, 135, 225, and 315. So those are all like pi fourths. So this would be a 3 pi fourths. And then that would be a 5 pi fourths, and then a 7 pi fourths. So those are all like the easy ones, like the 8, you know, the fourths powers and all that stuff. And then the ones that are sixths, I do next. So like the first one is a pi sixth, and then the next one is a 2 pi sixth, and that reduces to pi thirds, you know, as a fraction. And then if I add on another pi sixth, that would be 3 pi sixth, which would be pi halves. So I already have that one. And then I get 4 pi sixth, and then 5 pi sixth, and then 6 pi sixth, and then 7 pi sixth, and then 8 pi sixth, and then 9 pi sixth, and then 10 pi sixth, and then 11 pi sixth. And then I just like reduce them after that. So 4 over 6 is 2 thirds, so 2 pi thirds. And then 6 over 6 is 1. I already have that one. 8 over 6 is 4 thirds, so 8 pi 6 turns into 4 pi thirds. And then 10 pi 6, 10 6 turns into 5 thirds, so 5 pi thirds. And it looks like a lot of those angle measurements are already on here, so now I just got to fill in the sines and the cosines. Looks like I have a few tangents sprinkled in, but they're usually not that bad. Okay, let's I'll stick with the same colors, I guess, greens and all that stuff, because those help out to kind of flesh it out. Okay, so let's start with the blues. Yeah, blues. So let's see. The first one is going to be I like to think of them in terms of like coordinates. Like at the middle, that's the origin, and then I go out and up, and to the left and down by 1. So those coordinates are going to be like if I start at the origin, I go to the right 1 and up 0. That'd be 1 0. And if I go up 1, that'll be 0 1. If I go over to the left 1, that would be -1 0. And then if I go down by 1, that would be 0 -1. So that's like how I like to start it out. And then from there, I just like to kind of fill in the blanks with the fourths. The ones that have fourths are always like square root of 2 over 2s. And then you just pay attention to what quadrant you're in. So square root of 2 over 2. then that's annoying. There we go. Square root of 2 over 2. And then over here, that's going to be square root of 2 over 2, square root of 2 over 2. And then for the other one, 5 pi fourths, that's going to be square root of 2 over 2 and square root of 2 over 2. And then the other one, square root of 2 over 2 and square root of 2 over 2. And now we just pay attention to what quadrant we're in, and then you can put whatever signs that you need. So in the first quadrant, all the x's and y's are positive. Second quadrant, which is like over here, mark the quadrants also. In the second quadrant, the x value is negative, but the y value is positive, so that's going to be a negative there. Third quadrant, negative x, negative y. Fourth quadrant, positive x, negative y. All right, and then the last ones. So pi sixth, that one, if you just remember it like this, like pi sixth, it's like farther to the right than it is up. That'll tell you that like the x value is going to be bigger than the y value. So square root of 3 over 2 and a half. And then it's just the other one for all of the thirds. Now, every time that you see one of these pi 6 or a 6 in the denominator, it'll always have that combination on it. So 5 pi 6 is also going to have square root of 3 over 2, comma 1 half. And 7 pi 6 is also going to have that, square root of 3 over 2, comma 1 half. And the same thing with 11 pi over 6. It's also going to have square root of 3 over 2, comma 1 half. And then you just pay attention to the signs. So again, in second quadrant, negative x, positive y. Third quadrant, negative x, negative y. And then fourth quadrant, positive x, negative y. All right, and then for all the pi thirds, those are all going to be the same coordinate. It's going to be a half, and then square root of 3 over 2 for all of the the pi thirds. So like 2 pi thirds is also going to have that, a half, and then square root of 3 over 2. And then 4 pi thirds, same thing, 1 half, square root of 3 over 2. And then 5 pi thirds, same thing, 1 half, and then square root of 3 over 2. And then put in your signs. So first quadrant, positive x, positive y. Second quadrant, negative x, positive y. Third quadrant, negative x, negative y. Fourth quadrant, positive x, negative y. And that's our full unit circle. And I went through detail on all that stuff, but this will help us to answer all these questions. So let's answer them. Here we go. So the sine is always going to be the y value every single time, and the cosine is going to be the x value for all of these. Okay, so you can mark those on there as well if you want. If you can't remember the general pattern, this kind of helps out. I remember it in this way. You know how the coordinates go x and then y, right? That's alphabetical. X comes before y. Well, in sine and cosine, sine, cosine is c, so c comes before s alphabetically. So if you just remember that it's in alphabetical order, you can remember which one's sine, which one's cosine a little bit easier. That's how I always remember these little memory devices. That always helps me out. Okay, so let's find the sine of 30. So if we go over to 30 degrees, the sine is going to be 1 half. So that's equal to exactly a half. Sine of 60, so now we go over to 60 degrees. The sine is going to be the square root of 3 over 2. What about cosine of negative 120? Well, negative means that we got to go down 120. So if we start at 0 and then we go down 30 and 15. Well, I can think about it this way, right? I'm going this direction. Let's see. Let's use we can use red. That's fine. We go 180 degrees this way. That's 90 degrees. And then another 30 would put us right over here at 240. So it's really asking for the cosine of 240 degrees. So cosine is negative a half. And then cosine is 7 pi 6. So 7 pi 6 is right here. Cosine would be the first one, negative square root of 3 over 2. Cosine of pi halves. So if I go to cosine, pi halves is 90 degrees. That'd be 0. All right, and then tangent of negative pi. Well, if I go negative pi, right, pi is 180 degrees, so it's going 180 degrees either way. Tangent is kind of weird because tangent is going to be the sine value over the cosine value. So you got to kind of remember that when you're calculating all this stuff. So if I take the sine value, which is 0, over the cosine value, which is negative 1, That just gives me 0 overall. So 0 would be my answer for that one. Tangent of 0, again, tangent is going to be the sine over the cosine. So the sine of 0 is 0, and the cosine of 0 is 1. So 0 again for this one. And then cosine of negative 90 degrees. So if I go down 90 degrees, that's right over here at 270. So the cosine of negative 90 degrees is going to be cosine of 270, which is 0. Sine of 3 pi halves. So 3 pi halves is like right over here. And if I do the sine, that's a negative 1. And then cosine of negative pi fourths. So pi fourths is like the same thing as 45 degrees. So if I go down 45 degrees, that puts me at 315. So the cosine of 315 is going to be the square root of 2 over 2. And then the cosine of 300 is right here. Cosine would be square root of 3 over 2. And then let's see here, sine of 330 degrees. So 330 sine negative a half. Okay, so that's through the first 20. That's from 13 to 26. So that'll be the end of this video, and then we'll. What else do we have? Solve and stuff. Yeah, we'll just make that part of the last video. We'll do like 2 small videos for those ones. Okay, that's it for this one. See you in the next video. Bye bye.